Weaponeer. How's the IFI coming along?
Weaponeer to aircraft commander. IFI proceeding satisfactorily.
As you carefully check off each item of the in-flight insertion, Captain, you can tell that the preparation of the King weapon is moving along on schedule. But not too long ago, this weapon did not exist. To get King ready for Ivy, the weapon was being worked on in the States almost up to the last minute. So the weapon, minus the nuclear component, was ferried out to Quaj by a C-124. In the meantime, after the Mike shot, the Curtis sailed to Kwajalein. Assembly people from this ship work in conjunction with Sandia in preparing King for the airdrop. Following normal safety measures, the nuclear components of King arrive from the States in a separate aircraft. And now, this super-fission weapon, completed, ready, is taken from its shipborne assembly shop and moved under the cavernous belly of the waiting B-36. As the B-36 moves on its way to the target, the weather situation suddenly changes and becomes unsuitable for the test. And this means that the finely coordinated effort has to be canceled and the drop plane recalled to Quaj. For 72 hours, the King phase of Operation Ivy waits on weather. Men and machines who have been geared for the mission have to start all over again. Finally, shortly after dawn on November 16th, the go-ahead is given. This time, there will be no turning back. This time, King is on its way to the proof test for which it was created.
Weaponeer to aircraft commander. IFI completed.
AC to engineer. Set climb power.
And so the King bomber climbs into the thin air of the stratosphere and levels off at 40,000 feet, its bombing altitude. Here, the radar operator, or bombardier, if you will, guides the aircraft to that four-dimensional, yet imaginary spot so necessary for pinpoint accuracy.
Radar to AC, approaching target area.
The radar operator positions the aircraft in space with a movement of his hand, continuously running a cross-check between the radar bomb sight and the visual system, back and forth, first peering into one scope and then into the other. During these critical moments, the vital facts flit across his mind. Ground zero, 1,900 feet to the north of Runnet on the Coral Shelf. Height of burst, 1,500 feet. Allowable margin of error from ground zero, less than 500 feet. Zero. In the 56 seconds it takes the bomb to fall, the men of Operation Ivy wait on Parry and Eniwetok Islands. Unlike the Mike phase of the operation, the King phase will be observed from land. The bomb is now at 8,500 feet, at 6,500 feet, at 4,500 feet, at 2,500 feet, approaching 1,500 feet. Watch the air overrun it. what about Mike? Let us now go back and examine the evidence and point up the statistical highlights of that device. Remember those final last seconds?
5, 4, 3, 2, 1, T0.
This is the largest fireball ever produced. At its maximum, it measures about 3 1/4 miles in diameter. Compared to the skyline of New York, this means that with the Empire State Building as 0 point, the Mike fireball would extend downtown to Washington Square and uptown to Central Park. In other words, the fireball alone would engulf about 1/4 of the island of Manhattan. The tremendous upsurge of air from the detonation rapidly pushes up the Mike cloud. Again, nothing of this height and width has ever before been witnessed. If the picture is stopped at this point in the cloud's growth, the height of the cloud is approximately 40,000 feet. This means that 32 Empire State Buildings at 1,250 feet per building could be piled one on top of the other before they would attain the cloud's height at this time, roughly 2 minutes after 0. Some 10 minutes later, the cloud approaches its maximum. At this time, the mushroom portion of the cloud has pushed up to around 10 miles and spreads out along the base of the stratosphere to a width of about 100 miles, while the stem itself is pushed upward deep into the stratosphere to a height of about 25 miles. Later figures put the Mike yield at around 10 megatons, or 10,000 kilotons. This means there was more energy released in this one shot, roughly 10 times more than in all previous atomic blasts combined, including probably those of Russian origin. Or to put it another way, 4 times more power in this one shot than from all the high explosives dropped by the entire Anglo-American Air Force on Germany and the occupied countries during the last war. The results of this tremendous power can be shown at the atoll. Here is an aerial photo of the test area of the atoll before the blast. And here is the same area after the blast, showing the crater caused by Mike. The outlined island in the center is former Illugelab, the Zero Island. Sections of the islands on either side have been chopped off. The crater is roughly a mile in diameter. When it is illustrated that some 14 Pentagon buildings could be comfortably accommodated in this hole, the size of the Mike crater becomes more real. In profile, the crater gradually slopes down to a maximum depth of some 175 feet, or equivalent to the height of a 17-story building. The lateral destructive effects are the greatest yet observed from a single explosive device. Without getting into the areas of target evaluation or secondary effects, it can be safely assumed that there was complete annihilation within a radius of 3 miles, or out to and including all of Engebi, that there was severe to moderate damage out to 7 miles or down to Ruggiero, and that light damage extended as far as 10 miles or down to Runnon. Relating this area of damage to a city like Washington, D.C. would present a picture something like this. With the capital as 0 point, there would be complete annihilation west to Arlington Cemetery, east to the Anacostia River, north to the Soldiers' Home, and south to Bowling Field. Complete annihilation, and that is mentioning merely the primary damage.
Well, it's all over. Mike shot and King shot are history, and we're back here at Perry Island winding things up. It's been a pleasure to help bring you the story of Operation Ivy, the work of Task Force 132. Now that it's all over, I have sort of an inadequate feeling. There's so much more that could have been said. But then, in a presentation of this kind, one can only hope to give the broad brushstroke. And the men who told you the story, we're only able to pick out a few of the many. You get a feeling, even now, that nothing is really over. That this is a breathing spell, like a lull in battle before the next attack. The feeling is on this island, with the men here.
Yes, the coral sands of Eniwetok Atoll have viewed events in the fall of 1952, which less than a year and a half before would have been colossal accomplishments. Today, they are calmly accepted. This is characteristic of the progress being made in the weapons development program. What is new today is old hat tomorrow. And of the day after tomorrow, who knows what these Pacific sands may see?